Welcome. You are in for a really fascinating exploration today.
We are.
We're doing a deep dive into a new AI-powered robot. This one's from researchers at the University of Edinburgh.
And it's doing something deceptively simple yet complex for a robot making coffee.
Exactly, making coffee, but in a real kitchen. You know, messy, unpredictable.
hmm
Our main source here is a great report from azorobotics.com. It covers the research, which just got published in Nature Machine Intelligence. Pretty big deal.
That's a top journal, definitely.
So our mission today, we want to cut through the, let's say, the technical weeds, understand why this coffee bot is a big step,
Yeah, what makes it different?
and what it signals about, the future of intelligent machines. Think of this as your shortcut to getting what matters here.
And it really is interesting for anyone tracking AI or robotics.
Or even just curious about how tech might change, well, everyday life. This little robot actually tells us quite a bit.
It does. And maybe we should start with the baseline, the traditional challenge. Robots are great in some places, right?
Oh, absolutely. Factories, assembly lines.
Yeah.
They're brilliant there. Incredible precision, incredible repetition.
They nail those repetitive tasks. Flawless, really, hour after hour.
But that's the thing, isn't it? It's all about control. Highly controlled environments.
Exactly. Their strength is consistency in a place where nothing changes much.
But throw a curveball, something unexpected.
They often just stop or get confused. They rely heavily on those pre-programmed actions.
Which is why a kitchen is such a hurdle. Seems simple to us, but for a robot.
It's a minefield of unpredictability. That's the core difficulty, moving beyond the factory floor.
So what makes a kitchen so tough compared to, say, putting a car door on?
Well, think about it. In a factory, the car door is always in the exact same place.
Yeah.
The robot arm follows the exact same path.
Right.
In a kitchen, a mug might be here today, there tomorrow, in a different cupboard maybe.
Oh, okay.
And maybe that cupboard has a weird latch you need to figure out, or someone walks past unexpectedly.
Lots of variables. Stuff that fixed programming just can't easily handle.
Precisely. It's that dynamic nature.
Okay, so that sets the stage nicely for the Edinburgh team. What was their breakthrough? What did they manage to do?
Well, the really clever part, the achievement, is how they integrated things. They brought together advanced AI, really sensitive sensors, and very precise motor control, all in one system.
Integration. Okay.
Yeah, because as the Azo Robotics article points out, progress in AI, this sort of brain, and progress in the robotics, the body, or motor skills, often happen separately.
On parallel tracks.
Exactly. These Edinburgh researchers, they've managed to actually weave them together effectively.
So it's not just having a smart AI or a dexterous arm, it's making them work together seamlessly. That's the leap.
That really is the key advance here.
So let's picture this robot. How does it actually make the coffee? What's the process like?
Okay, so the robot itself is basically an arm. It's got 7 movable joints.
7. That's quite a few. Makes it flexible, I guess.
Very flexible. Much more like a human arm than, say, a typical industrial one. Gives it dexterity.
Gotcha. And the process starts how?
It starts with a voice command. Someone just says, make coffee.
Simple enough. Then what?
Then the AI part kicks in. It has to analyze its surroundings. It uses sensors, probably cameras to see, maybe 4 sensors in the arm to feel things.
Right, to build a mental map almost?
Sort of, yeah. A picture of the kitchen. It needs to find a mug. And here's a really interesting bit. It can apparently figure out how to open different kinds of cabinet doors to get that mug, even unfamiliar ones.
Wait, hang on. It can figure out how to open a cabinet it hasn't seen before. How? That sounds really advanced.
It does, doesn't it? It suggests a level of physical problem solving. It's not just following a script. It's reasoning about the physical world.
Okay, that's impressive. So it gets the mug. Then what?
Then it does the coffee part. It measures water from a kettle, mixes it with coffee grounds, apparently aims for a specific ratio.
Standard coffee procedure. But what if something goes wrong? Like someone bumps the cup while it's pouring?
And that's another key point highlighted in the article. It can adapt. It perceives that unexpected event, the bump, and adjusts its actions.
So it doesn't just spill everything and carry on regardless.
Apparently not. It shows an ability to react to the real world in real time. That's a huge differentiator from just playing back recorded movements.
So it's perception, action, and crucially, reaction based on new sensory input. Continuous loop.
Exactly. It's constantly perceiving and adapting.
Now, the article and the Nature Machine Intelligence paper it's based on use this term, embodied large language models. Sounds very technical. Can you unpack that a bit?
Sure. It's a core concept here. The paper title is actually Embodied Large Language Models Enable Robots to Complete Complex Tasks in Unpredictable Environments.
Right.
So embodied means the AI isn't just processing text or ideas in the abstract. It's connected to a physical body, the robot arm.
Okay, the body part.
And large language models you might know from things like ChatGPT AI that's good at understanding and reasoning, often based on language. So embodied LLMs means integrating that reasoning and perception ability of advanced AI with the robot's physical senses and movements. The AI isn't just thinking about the kitchen, it's in the kitchen, using its sensors to understand what's happening and directing its actions based on that understanding.
So the language model helps it understand the instruction, make coffee, and plan the steps. But the embodied part means it uses its eyes and feel to actually do it and adjust if needed.
That's a great way to put it. It grounds the AI's intelligence in physical reality and action. It's not just executing commands blindly. It's understanding, perceiving, and acting in a loop.
That makes a lot more sense. It connects the brain to the body through sensing.
Precisely.
Now, the lead researcher, Ruaridh Mon-Williams, the article quotes him. What's his take on the significance of this?
Yes. Ruaridh Mon-Williams, he's a PhD candidate involved with Edinburgh, but also Princeton and MIT. Quite the credentials.
Right. Speaks to the level of this work.
Definitely. And his quote really gets to the heart of it. He points out that, human intelligence isn't just about thinking. It's this seamless blend of reasoning, moving, and perceiving.
The integration again.
Exactly. He emphasizes that historically, AI and robotics kind of grew up separately. And his view is that this research really shows the power you unlock when you bring those elements, reasoning, movement, perception, together in a robot.
And he doesn't just see it as a lab curiosity, right? He talks about the future.
He does. He says something like, "We are glimpsing a future where robots with increasingly advanced intelligence become commonplace."
Commonplace. Wow.
Yeah. And he also makes the point that because of this, we increasingly need to talk about the societal implications. What does it mean when machines get this capable?
That's a really important point. It moves beyond just the tech itself.
For sure. It's not just cool engineering. It could genuinely change things.
And we should probably mention the funding, too. This wasn't just a side project. The Engineering and Physical Sciences Research Council, EPSRC, they funded this.
Right. That indicates significant backing and belief in this research direction.
So let's try and connect the dots here for you listening. This coffee robot, it's cool, yes, but it's a demonstrator, isn't it? What are the bigger implications here? Where else could this lead?
Well, if you can make a robot work reliably in a messy kitchen, that opens doors to lots of other unpredictable places.
Like what?
Think about elder care, maybe. Robots helping people in their own homes, which are all different and change all the time.
Okay, yeah. That requires serious adaptability.
Or maybe disaster response. Sending robots into damaged buildings or complex outdoor environments where things are chaotic and constantly shifting.
Situations where fixed programming would be useless.
Totally useless.
Yeah.
You need that ability to perceive, reason, and adapt on the fly. So this integrated approach could enable robots to take on tasks in challenging settings that, until now, really only humans could handle.
And as Mon-Williams pointed out, that capability naturally leads to bigger questions for society as these robots potentially become more widespread. Okay, so wrapping this up for you, our listener, this deep dive really highlights a significant step, wouldn't you say?
Oh, definitely.
The University of Edinburgh team, by integrating AI, sensors, and motor skills so deeply, they've shown a path for robots to operate much more effectively in the real, messy world.
It's a leap beyond those older, rigidly programmed machines.
And while making coffee is the example here, it really points towards a future, as the researchers suggest, where more intelligent, adaptable robots could become, well, much more common.
A future with potentially significant impacts on our lives.
Which brings us to a final thought for you to mull over.
Based on what we've discussed today, what other everyday tasks, or maybe what really challenging real-world problems do you think could be tackled next by robots with this kind of integrated intelligence and adaptability? Something to think about.